All right, it's time for lab 9, and this one is about recursion. So let's get on into it. So I've got a few files for you here, these guys, and it's just like a recursive functions library and then a test file with a main function that like makes sure they're all working. So here, the very first recursive function I want you to write is one that checks for palindromes. So do you know what a palindrome is? It's just any string that goes forwards and backwards. It's the same. It's like ABA is ABA forwards and also ABA backwards. That's a palindrome. AA race car is the standard example, right? It's a race car forwards and it's also a race car backwards, right? Those are palindromes. So for this lab, we're going to kind of make a fancier definition. We're going to consider that anything is a palindrome, even if there's spaces or weird capitalizations. So we're going to disregard spaces and capitals. We'll think that this is a palindrome. We'll consider this to be a palindrome and also this to be a palindrome. Does that make sense? So we'll have to clean up these strings before we test for the palindrome stuff. And yeah, with that in mind, let's look at the files. So for palindromes at least, you're going to need to clean up that original string that you're given. So here are your two files. You've got recursive function.h. Here's the declaration of the three things that you're going to be writing. And then we're going to talk about is palindrome first. All right. So yeah. Is palindrome, this one's going to be a two-part process. The original call to is palindrome on a string is going to need to be non-recursive. This one is not ready to be recursive. First, you need to clean up the string. You need to like convert everything to lowercase, get rid of the spaces. That's your first step, okay? For palindrome checking, there's two parts to it. So you'll have, this is like the helper function. Is palindrome is a helper function. It takes the original string that's maybe like weird and has spaces in it and cleans it up, becomes that out of this one. Does that make sense? So you have to like make a brand new string, get rid of the spaces, get rid of the capitalization, and then you're ready to do recursion. All right. So like create the new string, get it ready, and then down here, all these functions down here, these are the recursive ones. Then you'll use an is palindrome recursive function to do the actual palindrome checking on the string that you have made pretty and pre-processed. Okay. So it's like turn this into normal race car and then hand it off to your is palindrome recursive problem that actually checks for whether or not it was palindrome. And like its answer is your answer. Does that make sense? That's what's going to go on here. Okay, so yeah, this is the one non-recursive function. It's going to call the palindrome checking recursive function though. All right, so yeah, that is the secret there. And yeah, here's my diagram, my helper diagram for you. So in your recursive function, you have to recursively get given a string, check and see if it was a palindrome or not, true or false. And so how do you do that? You have to turn your bigger palindrome solving problem into a smaller palindrome solving problem. Can you find a smaller palindrome to check inside of race car? That's going to give you your strategy. And then based on what the smaller problem like checks for you, what do you have to do for your original bigger string to guarantee that it really was a palindrome after all? Does that make sense? So that's what you're going to do. There will be two base cases for palindrome checking because think even strings versus odd strings. That's my hint. All right. And so for base cases, just think about this. For which strings do I immediately know whether or not they're a palindrome? There should be two special kinds of strings that you immediately, just looking at them, you know that they're the same forwards and backwards. All right. So using this diagram, try to break it down. And that will turn into a recursive case, and then think about your two base cases. You got to make progress towards those, and then you're going to give back true or false, depending on whether your original string was a palindrome or not. All right, so make your recursive calls, use the answer. All right, use that answer that the recursive call gives you back. And so, yeah, that's your first one. Then you have two more recursive problems I want you to try. All right, so these have to be done using recursion. So the next one is sum up the digits in a number. So this one, you're given a number and you give up the sum, you give back the sum of all the digits in the number and you do it recursively. So some digits on 123 should give back 6 because that's 1 plus 2 plus 3. Does that make sense? That's some digits' job, and like the sum digits on 1234 should give back 1 plus 2 plus 3 plus 4. And so, yeah, it should be 10 for that one. Yeah. And so here is your recursive case hint. You can break down the problem into this. Your original problem turns into, right, the answer is here. There's your smaller problem. Can you generate that and solve for it and like add on your extra work, your extra digit? Does that make sense? And then you'll eventually chop it off into a number with no digits, maybe? So you'll have to think about that base case. That'll be fun. That's sum digits. You got to do it recursively. Break down into a smaller sum digit checking problem. Sum the digits of 123, something like that. And then finally, your last recursive problem is string length. So I want you to do like a strlen function on a C string. All right. So you can't call strlen. That would be cheating. It has to be recursive to check the length of the string. All right. So you're given a C string, and your job is to give back how many characters are in it. All right. The length of it in terms of normal characters. The length of an empty string, remember, that's just a null terminator character. That's 0. So this, even though it's ASDF null terminator, the string length should be 4. It's how many real characters are in it. And so yeah, your job is to do this. You're given a C string. You're supposed to give back its size. It's 5. And here's one way to break it down. So you're going to have to break it down into a smaller string size checking problem. And then you do a little bit of extra work to build up your original answer. Do you see that? That will turn into your recursive case. And remember to call your function on the smaller string, you'll add 1. It's pointer arithmetic, because a C string is represented as a pointer to the beginning of it in memory. So you're going to add 1 to get to a pointer to the next character from LO onwards or something. Does that make sense? So that's going to be your recursive case. And then think about your base case. When do you have a string that you immediately know the size of? You don't have to do any extra work. Okay, think about that. That, I think, is what I wanted to say. All right. So yeah, just follow the comments, read the hints, and that should work out. Okay, so I've made a main file for this. Did I give you a make file? I did not. So here I am. I've got some tests for you. You don't have to write any of your own, but here they are. We've got some palindrome tests. I'll just make sure like these things are palindromes, these things are not palindromes, stuff like that. All right. And then some digit tests. And then here are some string length for C strings tests. Okay. I hope that makes sense. Not too bad. Just the trick is going to be figuring out the recursive cases and the base cases for these guys. All right. And then remember, for is palindrome, you have to clean up the string first, get rid of all the spaces and the capitals, and then make the capitals lowercase, and then you can hand it off to your is palindrome recursive problem to do the rest of the work. And that's the answer that you give back, the one that this one gave. Does that make sense? That's what you're going to be doing. And then all the rest is recursive. So yeah, I think it's fun. I love recursion. I'd be happy to help if you have any questions about anything. And yeah, you're not making any of your own tests this time, so you're just going to turn in your implementation of that recursive function library. Okay? And that's it. That's all that I have to say. I think that is your Lab 9. Please start early, keep track of that due date, and ask me lots of questions.